प्रतीक्षा के साथ भी यही हुआ। तीनों तीनों बच्चे
Hi guys, good evening. How are you all? Yes, guys, how are you all? Okay, so let's start the class, guys. Today, today will be my last class for sure because I think I have taken too much time. I would have finished in two classes, but I would have taken, I have taken four classes now. Okay, this is the fourth class. But for sure, for the theory, I think it was needed and you must understand the things in details. Okay, so let me share the screen, guys, with you and let's start. Okay, yeah, we left here yesterday. Yes, we left here yesterday. We're not going to talk about everything, but yeah, some things, just few things we'll talk. Okay. I hope you are able to see the screen and you are able to see the incidence prevalence what we have done yesterday. Guys, please confirm. Are you able to see the screen with incidence and prevalence comparison? Okay, fantastic. I believe yes, it is there. Okay, great. So guys, see, as we have learned about incidences and frequencies in epidemiology, so I'll just revise it. What is the major difference between incidence and prevalence? Is the total number, okay, like old plus new. Incidence is total number of new cases divided by total exposed population or total exposed, total exposure. Okay, so incidence like usually is used in cohort studies and prevalence used in cross-sectional studies. Brought in cross-sectional studies because in cross-sectional studies we take the old thing also. How can we join GPET classes? They are going simultaneously. You can check the recording of one. It's okay. I mean, if you want to go to GPET class, it's fine, perfectly fine. You can take the recording of this. That's perfectly fine for you, Hanu. Okay, and I think that's more important right now. So you can go to the GPET class. It's perfectly fine. Okay, guys. So the measurement where we usually do is the difference here is like cohort studies are being done in the being done with the incidences. We talk about the new cases. Why? Because cohort studies are remember forward directional, right? Forward direction. So forward direction means we always look for the new cases, and cross-sectional studies are backward direction, right? Backward direction. So backward is direction means like we are taking old plus new cases also, right? I mean, we're taking new cases, but we have to count the old cases also. So prevalence is usually used in cross-sectional studies and incidence is usually used in cohort studies, right? And incidence, like the total new cases, prevalence, total old plus new cases, right? So what is the measures of association? First of all, what is the measures of association? Why we need the measures of association? Measures of association means usually it belongs to the probability, like measuring the association between two factors, measuring the association or correlation between two factors, like suppose there is factor A, there is factor B. So in the association or correlation we always check how much A is impacting B and how much B is impacting A. Like suppose friends A and B, friends A and B, studying in a college, they're very close friends. So definitely the presence of A will affect the marks of presence B. I mean marks of the B, and presence of B will affect the marks of A in the final exams. Definitely, because maybe they are, maybe one is very very hardworking and studious, another one is not that much, right? So it will definitely somewhere it will correlate with each other, like how they are doing the activities, how they are playing, how much they are studying. So that all depends on each other, whether it is too much or whether it is very less, but there is some association, there is some correlation between two factors or two friends. Like, so what is exactly the measures of association? This is like the impact, okay, the impact or effect or affect, okay, effect actually. Okay, so the effect of factor 1 on factor 2 in a similar environment. in a similar environment is called as measures of association. When we measure this association, when we measure the relationship between two factors, that is called as measures of association. I'll give you the medical example here, the clinical example here. Suppose, you know, hypertension and salt intake, right? Salt intake, okay, and then alcohol, then, smoking. Okay, so hypertension is the IV here, independent variable. Sorry, a DV here, dependent variable, and all these are IV. All these are independent variables. Okay, all these are independent variable. Hypertension is depending on salt intake, alcohol, and smoking. But it does not mean that smoking is not depending on alcohol or alcohol is not depending on salt intake. I mean, there is some relationship also in between. When we check the correlations in between, there is some relationship, there is some association in between also. Because see, maybe salt intake may not be directly correlated with alcohol or may not be associated with smoking, but when in aspect to hypertension, when we measure all the associations, then definitely it goes with some association or some relationships and some impact of each other on each other. Like, if statistically we check the risk factors, these are the risk factors, right? If we are checking the risk factors, impact of risk factors on hypertension, then there is definitely some impact of the factors, risk factors, on each other also, right? There is some impact on each other also, right? That is called as measures of association. So measures of association is not only between salt intake and alcohol, it is there between salt intake and hypertension also. It is there alcohol, hypertension, smoking, hypertension, smoking. I mean, wherever there are two things associating to each other, that is called measures of association or correlation, where we are trying to establish the relationship, right? So what are the measures of association? There are usually two only. Okay, in statistics we have only two measures of association. One is odds ratio and one is relative risk. Odds ratio and relative risk. So in case controlled and cross sectional studies, usually we take odds ratio. Okay, we take odds ratio. I'll tell you what's odds ratio. And in cohort studies we take relative risk. So odds ratio means is like how much it is depending on other, like, okay, we are expecting some rain today, and the other factors also, how much we are expecting the rain because of the other factors, maybe because today is too much sunlight, or maybe too much hot environment, and we can see the black clouds and all. So the how much odds of getting rain today, how much odds or getting rain today are happening, that is called, when we are associating these two things, two factors, that is called odds ratio. Okay, and the relative risk is like how much risk one factor is putting on others to cause it. Okay, to cause it, that is called risk, relative risk. Okay, I'll explain the next slides. When we do the interventional studies like clinical trials, we check both odds ratio also, relative risk also. I mean, either of these, one, odds ratio or relative risk, or maybe both odds ratio and relative risk, we check both. So remember this: case control and cohort study we check odds ratio, sorry, case control and cross sectional, and cohort studies relative risk. Interventional we check both. Okay, right, guys? Now, see, look at this relative risk. First, let's talk about relative risk. The ratio of incidences of the disease among exposed to non-exposed is called risk ratio. Okay, it's called as risk ratio. It's called as risk ratio or relative risk. Okay, risk ratio or relative risk. Like, it is very simple: incidence of disease among exposed and incidence of disease among non-exposed. In the clinical scenario, that is like the formula to check the relative risk or risk ratio is incidence of disease or death, whatever. Incidence of disease among exposed, incidence of disease among non-exposed. Like, say, I was talking about the lung cancer, right? Smoking and lung cancer. So here, incidence of disease among exposed is like how much smokers are getting lung cancer. Here, how much non-smokers are getting lung cancer. Right? Just take the ratio of it. That is risk. That is risk ratio or relative risk. like the incidence of disease among exposed people and incidence of disease among non-exposed. So ratio of these two is called as relative risk. Now look at this. The direct measure is strength of the association. Okay, direct measure is strength of the association. What about passive smokers? Passive smokers are also like this is also the risk factor. So when we are talking about risk, when we are talking about smoking in the lung cancer, we have to think like how we are taking the data. If we are taking only passive smoking, active smoking, then we count like how many years of passive smoking, how many years of active smoking, how many bags per month, bags of cigarette, right? So there are multiple things we check it, right? So that is the part, that is the technical part, how much we are taking, right? So here we are talking about the statistics. Here we are talking about statistics, and the statistics, what is relative risk? Relative risk is very important association, guys, and very important to check is like incidence of the disease or death among exposed divided by incidence of disease or death among non-exposed. So this is the ratio. So there is very important thing. If there is RR 1, if RR is 1, there is no association. Okay. If the incidence of disease among exposed and non-exposed is same, okay, then only it will come 1, right? If it is like 10 by 10, then only it will come, right, 1. So the incidence of disease among exposed is equal to among non-exposed, right? That means like the exposure is also not causing any special impact. Understand that exposure is also not causing any specific impact, right? Suppose let's take this example only, right? 10 out of 100 smokers are getting lung cancer, and similarly 10 out of 100 non-smokers are getting the cancer. So what's the impact? It is equal to 1, right? So there is no association, there is no relative risk, because smokers, non-smokers are getting same thing. So smoking is not affecting the people at all. You understand? Smoking is not affecting the people at all. So exposure is not affecting the people, affecting the population at all, right? That is RR is equal to 1. If your relative risk comes 1, there is no association. And if the relative risk comes more than 1, guys, if the relative risk comes more than 1, then there is a positive association or harmful association. When it will come positive? When there is like 20 out of 100 smokers are getting lung cancer, and only 10 out of 100 non-smokers are getting lung cancer. So non-smokers are getting less. So what will be the risk ratio here? 2. Risk ratio will be 2. So we can say that smokers are getting 2 times higher lung cancer than non-smokers, right? Than non-smokers. So RR is more than 1. That means there is a positive association, and that is harmful. Positive association is always harmful here. Positive association is always harmful here, right, guys? Okay, remember this, positive association is always harmful. And negative association means protective, like, oh, among exposures only 10 by 100, and among non-exposures 20 by 100, right? 20 by 100. So that means only 0.5. That means even smokers are getting less lung cancer than non-smokers. You understand that? Smokers are getting less lung cancer than non-smokers. So that means smoking is protective here. Smoking is protective here. Smoking is protecting against lung cancer. I mean, I'm just talking about the example. So here, if the negative association comes, if the RR comes less than 1, that means the effect is positive, effect is negative. Now I'll tell you how it goes, how you check it, and how you work on it. How you work on it. Like, you need sense of humor also when you are calculating and checking the RR. I'll give you two examples here. I'll give you two examples here. One is smoker, non-smokers only. So there are 10 smokers. I mean, we are taking 100 participants. So 10 smokers are getting lung cancer. Okay. And 20 non-smokers are getting lung cancer. So that means it is 0.5. 0.5. That means the smoking is protective. How bad it is? Smoking is never protective, but it is showing that smoking is protective. So in such cases, we don't go for like relative risk, and we usually don't, we check immediately. First we check what we are exactly measuring. But if I'm giving the same example, if I'm giving the same example for drug A versus drug B. Drug A is control, drug A is control, right? Drug A is control, drug B is case. Like whatever we are giving the drug, right? Our investigational drug. So if it is 20, if it is 10, if it is 20, if it is 10, the case is getting 10 only, and incidence in the control is getting 20, right? So how much it will be? 2, right? The incidence ratio, the relative risk is 2, right? That means the drug A, the drug A control, the drug A control is what? Control is what? Control is not good, and the case investigational drug what we are giving is protective. You understand that? In that cases, like, so we have to think what we are exactly doing and how we have to take the result, how we have to interpret the results. So here, the drug, investigational drug is protective because in the control, maybe that is placebo, there are 20 diseases, 20 problems, the 20 cases among the population, and in the investigational drug only 10 cases. So this drug is protective. This drug is having better efficacy and better impact, better protective impact. Understand that? So that's how we check it for. So let's see the examples and then we can go ahead, guys. So I hope you understand that. Did you understand this? Any questions? Okay, I'll give you the examples here. So yeah, I'll give you the examples here. No worries. It's simple actually, nothing to understand. See, the example here is, smoking and myocardial infarction. See, out of total 500 individuals, 80 are smoking, and among 120 MI patients, 45 are smoking. Find out, is there any association between occurrence of MI and smoking or not? This is the question. That type of questions you will get. So the thing is, first construct a 2 into 2 contingency table. First you have to make a table like this. 2 into 2 means 2 rows, 2 columns, 2 rows, 2 columns. Okay, so how the question gives only this number 500. Total number is 500. Okay, so write the total number 500 here, and then check out, then check out among 500 how many are smoking, how many are smoker. 80. Total smoker numbers are 80. Smoking, yes, is here. Total smokers are 80, and total among MI, how many MI are there? MI are 125 here, 125, right? So now you can easily make the table. Right now you can easily make the table because they says that 45 are smoking among 125 MI. So 45 comes here. You can easily calculate 125 minus 45, 80, right? 125 minus 40, 80. Now 80 minus 45, 35. Then 500 minus 80, 420. 420 minus 80, 340. Right. So your contingency table is ready here. Your contingency table is ready here. Now check the relative risk. First of all, you have to check incidence of MI among smokers. You have to check the incidence of MI among smokers. So here is, let me show you MI among smokers. So what are the smokers? Smokers are 80, right? And MI is 45. So 45 by 80, incidence is 0.563, right? Then we will check incidence of MI among non-smokers. MI non-smokers, MI is 80, non-smokers are 420. 80 divided by 420, 1.1, 0.191. Relative risk of for MI is incidence of MI among smokers 0.563 divided by 0.193, 2.95. Relative risk is 2.95. That means the implication says, it implies that smokers are 2.95 times at greater risk of developing MI than non-smokers. Understand that? It is a negative effect. It is not the protective effect, it is harmful effect. So smoking has the harmful effect on developing the MI. You understand that? 2.95 times higher. So that's how we interpret the relative risk. It is very simple. Whatever the question is, first prepare the 2 and 2, 2 by 2 contingency table, and then calculate the relative risk, and then calculate the incidences, and then calculate the relative risk. Understand guys, very simple. Okay. Now we'll go to the odds ratio. Odds ratio is the another thing. Okay. So what is odds ratio? Odds ratio is the measure of the strength of association between risk factor and outcome. Again, same thing. You have to prepare the two by two contingency table. Okay, 2 by 2 contingency table you have to prepare. Right, same thing. A plus B, C, D, C plus D, A, C, A plus C, B, D, B plus D, and total is A plus B plus D. Okay, same thing we were seeing in the last section of relative risk. Now odds ratio will be calculated similar, but the formula is a little different. How is the formula here? How the formula works here? So odds ratio is nothing but the kind of probability. So the formula of odds ratio is very simple. A divided by A plus B, B divided by A plus B, and the whole is divided by C divided by C plus D, and D divided by C plus D. Okay, that is the odds ratio. Now how to calculate it and what exactly the odds ratio is? See, the odds ratio is the ratio of the odds. Odds means the probability. Odds means the probability. You understand that? Odds of happening something. Odds means the probability of happening something. So probability of an event occurring in one group to the odds of it occurring in another group. Like the comparison, association, how we check it, like the probability of happening something in one group and probability of happening something in another group. The same thing what we were doing in the incidences, but here we are not checking the incidences. Here we are not checking the ratio of incidences. Here we are checking the incidences of odds. Odds means the probability. So simple. Wow, how to difference relative risk and odds ratio? Relative risk means incidences, the ratio of incidences. Odds ratio is what? Odds ratio is the ratio of probabilities. Okay, so odds in the favor of an event is ratio of the probability. Okay, that an event will happen. P, event will happen means the probability P to the probability that it will not happen, 1 minus P. So it is very simple. Odds is happening divided by not happening. Happening and not happening. Ratio of happening and non-happening. P is probability and 1 minus P is no probability. Right? Simple it is like. If P is probability, if P is probability of happening, then 1 minus P is not happening. Right? So here we are just checking odds is what? Odds is like P divided by 1 minus P. Simple. Very simple. Odds is very simple to calculate. So example, probability that today it will rain is 0.02, like 20%. Happening the rain, the probability of rain is 20%. So how to check the odds? 0.2 divided by 1 minus 0.02. I mean 0.2, right? 0.2 minus divided by 1 minus 0.2 is like 0.8. 0.02 minus sorry 0.2 divided by 0.8 is equal to 0.25. That means 25%. That means 25%. Probability is 0.2, but again the odds means the ratio of probability is at 25%. Odds of happening the rain is 25%. Remember, it is very simple to calculate and very simple to understand. Relative risk was the ratio of incidences of happening and non-happening. I mean exposure versus non-exposure. Okay. And then odds is the ratio of, like, again the probabilities. Okay, odd is the ratio of probabilities, odds ratio, right? Understand that, that is, it comes in percentage. Now here look at this, it's very simple. A divided by A plus B, A into B, C to D, and then divide the whole thing, like A divided by A plus B, B divided by A plus B, then C divided by C plus D, D divided by C plus D. Okay, here this is right. So if you see, one factor is this, one entire factor is this, it will go up, it will go down, right? So how it will come? A into D and B into C. So here it is shown directly. Okay, the final formula here, it is directly, they have shown directly, like A into D divided by B into C, right? A into D divided by B into C. So it is very simple, like just cross it. So A into D divided by B into C. Number, simple. Here, look at this. Again, same thing. 500 individuals, 80 are smoking, 125 MI, 45 are smoking, find out, is there any association between occurrence of MI and smoking? Same contingency table, just A, this is A, this is C, this is B, this is D, right? Same thing, but the formula has changed here. There was, we are checking the ratio of incidences here, just keep it A into D, B by C. 45 is A, 45 into 340 divided by 35 into, sorry, divided by 35 into 80, 35 into 80. So the entire thing comes is 5.46, odds ratio comes is 5.46. So now here is the probability of occurrence of MI in smokers is 5.46 times higher than the non-smokers. See, the implications are similar. There were, I mean, similar means we have to find out same thing. But in the relative risk, it was 2.9 times higher. But in odds ratio, it is 5.46 times higher. Okay, what's the difference? The difference is only one, that for the different scenarios we have to check. If we are doing the retrospective, I mean, if we are doing the cohort study, if we are doing the cohort study, then we check the relative risk. If we are doing the backward direction studies like case control or cross sectional studies, then we go for odds ratio. Understand that? Remember this. What is the difference? There is nothing much difference in that, but the only difference is if we are doing the backward direction studies, you have to remember that these are the assumptions. If you are doing the backward direction studies, odds ratio. If you are doing the forward direction studies, the relative risk. Simple. And both are the relations between the happening and non-happening between the factors. Okay, guys, understand any other things what you want to understand here? Anything, guys? Now we'll go to the next part of the presentation. Yes, guys. Any questions till now? You understood or not? Odds ratio and relative risk. As you're not saying anything. Clear? Great. If understood, very fine. Now, the final thing before we dive into the SPSS is types of tests for significance. Significance, first of all, significance is what? Significance is like there is a group A, there is a group B, right? There is a difference between A and B. There is a difference in between A and B, as we were talking in the first class. Like there are 100 students in class A, 10th A, suppose 10 A, right? And then 100 students in 10B, right? Their mean, mode, median are similar, but we have to find out if there is any actual difference, what exactly the differences are, right? What exactly the differences are, mean, mode, median, and if this difference between these two classes on the individual basis or whatever number, we'll get the difference between two groups. Okay, we'll get the difference between two groups, and we have to find out if this difference is significant or not. Significance means what? Okay, significance means what here? Significance means the chances of errors. If there are chances of errors more than 5%, or there are like Dr. Siddesh will take in the next class, like there are two types of error, alpha errors or beta errors, right? Alpha errors or beta errors, right? So he will take those things, okay, about the error. So we always try to find out what is the exact difference and what is the exact, the difference is significant or not. Significant means if we can report it that there are certain errors or not. There are certain errors or not, right? So to check the significance, we always consider p-value, right? Guys, you know that p-value, if we want to know the significance, we go for p-value, and p-value is usually, we consider 0.05, as I told in the last class also. 0.05 means 5%. So out of 100, we consider that our data is having less than 5% of errors, and it is 95% confident. We are 95% confident that our data is correct, normally distributed. Got it? Your data is 95% correct. You are having the high confidence on your data. You have a high confidence on your data. Now, what is exactly the significance? Significance is like if there are two groups, in the two groups, if the errors are less than 5%. If the errors are less than 5% and they are matching, then that difference is significant. Difference is significant. Okay, difference means, like, see, errors are normal, but still there is the difference. Mean might be similar, mode might be similar, but still there is significant. But if the errors are less than 0.05, the p-value is less than 0.05, that means having the less error, we have a difference. Having the less error, there is a difference, that is called significance. That is called significance. Okay, understand that, that is called significance. I mean, not the difference exactly, but having the less error, there is a significance, that is called I mean, there is a difference, that is called significant. So that's why we take p-value less than 0.05 usually. I mean, in different cases there are different. Usually in the big clinical trials we consider 0.02 also, I mean 0.2 also. So they consider the errors up to 20% is fine. They take 20% errors are fine. Somewhere this is like 0.01 also, less than 0.01 also. Okay, like 0.1 or 0.001. So they take only 1% error or 0.1% error. Okay, so it is depending on what type of clinical trial or what type of trial or what type of study you are doing. It decided based on the study, but usually worldwide we take p-value less than 0.05. Okay, it does not mean that it cannot be 0.2, 0.01, 0.001. It depends on the investigator and the study, what type of p-value you want to consider. You want to consider for it. Okay, guys. Now in the significance, when we check, there are two types of test we do to check the significance. One is parametric test, one is non-parametric test. Now leave everything and go back to only one thing: data types. Okay, go back to only one thing: data types. In data types we learned one thing, that was distribution, right? That was distribution. If the data is normally distributed or not normally distributed, right guys? Normally distributed, not normally distributed, there are two things. I mean, not normally distributed could be negative, positive, skewed data we call it, right? But normally distributed means where mean, mode, median, we feel that data is equally distributed. We don't have outliers, we don't have many extreme values. The data is normally distributed. We have the normal data with us, right? So what exactly the normal data is, that we have seen before, but now the test types. So whenever we have normally distributed data, whenever we have normally distributed data, we go for parametric tests. And whenever we have not normally distributed data, we go for non-parametric test. But there is a catch, guys, you have to understand. The parametric test can be done only for the normally distributed data. Parametric tests can be done only for the normally distributed data, but non-parametric test can be done for both. Okay, non-parametric test can be done for the data which is normally distributed or not normally distributed. It will give the results for all type of data. So why we do the parametric test and why don't we do only non-parametric test? That's the question, right? The next question from you should be why we are doing the parametric test then, and why we are not doing the non-parametric test. I'll give you an example. Very, very fit example here. I'll give you. You have 10 gram of gold. 10 gram of gold, right? 10 gram of gold. You want this gold, 10 gram gold, and you want to make a ring out of the gold. Ring out of the gold, right? That is your final outcome. 10 gram gold, you want to make it a ring. So where you will go to make it a ring? Where you will go, guys, to make it as a ring from the 10 gram gold? Goldsmith. You will go to goldsmith, right? You will go to goldsmith. But the same thing can be also done by what? The person who is making the iron rods, and what we say in the English, that guy, the person who works on the iron thing, there's something I forgot. Lohar, Hindi mein lohar bolte hain usko. What we say in English, I forgot that guy. Blacksmith. Yes, blacksmith. So blacksmith also can do that work, right? Blacksmith also can do that work. Goldsmith can also do that work, and blacksmith also can do that work. But if it is a gold, why we are going only to the goldsmith and why we are not going to the blacksmith? Guys, tell me the difference. I mean, blacksmith also can do that, but why we are going to the goldsmith only? Any answer? We have different skills and instruments. Okay. Costly non-perfection. Exactly. The thing here is, if we are going to the blacksmith, we will not get the quality, perfection, or if we mix these two things, there is one word called, we will not get precision. We will not get precision, precise results. We want precise results. We want precise results. Understand? We want precise results. So with the normally distributed data, with the normally distributed data, if we are going to parametric test, we will get precise results. Now I'll come to the instruments, because parametric tests are having the algorithm which is made. The algorithms are made to check only the normally distributed data. So they give the precise results. Non-parametric tests are for not normally distributed data, and are known for only known for non-parametric non normally distributed data. They can also be checked. Okay, I mean, normally distributed data also can be checked in non-parametric tests, but it will not give you the precise result. It will not give you the precise results. Okay, that's why we do parametric test for normally distributed data and non-parametric test for not normally distributed data. Okay, in certain cases, like where you don't know how to do the parametric test, you can, and you know the non-parametric test, you can do those, right? So here, like what exactly we want, like see, continue parametric test. These are the tests applied for the data which is following assumptions. First of all, continuous type of data which is normally distributed. Continuous type of data. Parametric tests are only used where there is one data which is continuously, which is continuous. Okay, so you remember continuous, there were two types, qualitative and quantitative. So quantitative, there is continuous and what? Continuous and continuous and discrete. Yes, continuous and discrete. So if the data is continuous, then we go for parametric test, and this data also should be normally or near normal distributed. Okay, and the test for parametric is student t-test and ANOVA. Student t-test and ANOVA are the examples of parametric tests. Student t-test and ANOVA, right? Non-parametric tests, right? So see, not only the in the parametric, not only the student t-test and ANOVA, but all the like ANOVA, independent t-test, paired sample t-test, all are parametric tests. All are parametric tests. All are for normally distributed data, because we have one variable that is continuous data and it is normally distributed. Okay, and how to check the normal distribution or non-normal distribution can be done by Leibniz test. Okay, we can run the Leibniz test for our data, and we can come to know based on the p-value. Dr. Siddesh will tell you. He's taking the class on Leibniz test and all. So I mean, I'm not taking. So he will be taking the Leibniz test and all. He will tell you how to get the normally distributed data. First, check the Leibniz test. You will see if the data is normally distributed or not normally distributed. Based on that, you will choose the test, which test to do, parametric or non-parametric. Okay, so parametric tests are like student t-test, paired t-test, independent t-test, ANOVA. See, all these tests are parametric tests where we use continuous type of data and normally distributed data, right? Okay, now the second thing is non-parametric test. Non-parametric test, like where the data is not normal and it is not possible to make it normal distribution. I mean, we cannot even make the data to normal distribution, right? We cannot make it to the normal distribution because the data is either categorical or counted. Counted means discrete, right? Discrete, either discrete or categorical. We cannot make it normal. We cannot, because we cannot make it continuous. We cannot make it continuous data and we cannot make it normal. So all the non-parametric tests are done for the discrete or categorical type of data. For the categorical type of data and discrete type of data, we go for chi-square test, Wilcoxon sign rank test, Mann-Whitney test, Kruskal-Wallis test. These all tests are being done for non-parametric test. See guys, one more very important thing you have to understand here. One more very important thing I'll tell you here, what exactly is these tests and what exactly the non-parametric parametric depends on. There are two types of data, right? We know qualitative, quantitative. No, but there are two types of variables also. One is independent variable, one is dependent variable. Okay, one is independent variable, one is dependent variable. So the dependent variable is what? Dependent variable is, as I was telling you, like which is depending on others, which is depending on others, and independent is like which is not depending on anything else. Usually that is directly affected by all. That is directly affected by all or affecting the all. Okay, so that is independent, that is affected by all is independent, and affecting all is dependent variable, right? So see, when we have independent variable continuous, then parametric test. If the independent variable non continuous, I mean the categorical or discrete, that means the non parametric test, right? So it depends on the independent variable. Does not mean that like what we say in the last test, if we have like paired t-test. In paired t-test, we need both the variables as continuous type of variables, in independent t-test, the dependent variables are, I mean, it could be categorical also, but the IV independent variable would be what? Independent variable must be continuous type of data only. Okay, so it always depend on in the the independent variable. Whatever independent variable you have, based on that nature, you will decide like what type of test you are going to take. Okay, in that also you will see the normality by Leibniz test. Okay, you will understand when we are doing it practically. Okay, so here is the comparison of parametric non-parametric. As you can see here, listen guys, here a little bit careful. Distribution, if it is normal distribution, then we go for parametric test. If it is any kind of distribution, non-normal or normal, we can go for non-parametric. If the data is assumed homogeneous, we go for parametric. Homogeneous again is related to normally distributed. There is no extreme values. Homogeneous means no extreme values. The non-parametric, homogeneous, heterogeneous, all type of data can be analyzed by non-parametric tests. Type of data, ratio or interval means continuous type of data, parametric. Ordinal, nominal means categorical type of data, non-parametric. Okay, mean means continuous type of data, again parametric. Median, like categorical type of data, non-parametric. You understand? Where mean cannot be checked. Mean cannot be checked in certain situations where like either data has lot of extreme values, or mean cannot be checked only where data has lot of missing values, extreme values, and either the data is not continuous type of distribution, right? So median, non-parametric, right? And then the tests are like, if it is correlation test, then in parametric Pearson test, non-parametric Spearman test. If the independent measures having two groups, independent variable has two groups, like maybe independent variable has two groups like the gender, male and female, then independent, I mean in the parametric data, independent measure t-test. In non-parametric, Mann-Whitney test is the counterpart of that. If the independent measure is having two groups, then parametric we go for ANOVA, and in non-parametric we go for Kruskal-Wallis test. You will not remember this, I know, but it is just to understand. Okay, repeated measures, two conditions, matched pair t-test, as I told you, pair t-test, and non-parametric Wilcoxon test. So what is repeated measures? Now I'll give you the examples. Independent measures, two groups. Like I want to check the age between male and female, right? So age is continuous data. Age is continuous data for like what we are taking. So if it is a parametric, then age is continuous data here, and male and female are what? Male and female are the categories, two groups, right? Two groups. So we'll be checking this again. You will be checking this in age category. I mean age in male, age for male, and age for female. There will be age for everyone, but we will check for male and female, two groups. So if we are applying parametric test, I mean if the data is normally distributed, then parametric test, Pearson, I mean this independent measures t test. If non-parametric, then Mann-Whitney test. More than two groups, like education, not educated, or primary, higher secondary, or the graduation, more than graduation. There are multiple groups, and we want to check the blood pressure of multiple groups. So BP is again continuous here. If it is normally distributed, then the test will be ANOVA, right? Because the groups are more than two. Okay, and continuous type of data is normally distributed, so parametric test will be ANOVA. And if it is not normally distributed, Kruskal-Wallis. Similarly, repeated measures, guys, it is repeated measures. If I come to the repeated measures like blood pressure, if we are checking the blood pressure of one person today and tomorrow, so it is a repeated measure. Or maybe the baseline, I mean we do the lot of medical studies, baseline or after baseline and then after 1 month, baseline and after 1 month, right? Baseline and after 1 month. What's happening? Baseline and after 1 month. So it is repeated at baseline and after 1 month. So there are two things, continuous type of data only. The two types, two datas are continuous only. So in like repeated measures for two times, matched pair t-test, and the non-parametric, the data is not normally distributed, then Wilcoxon test. Okay. And for other than that, if there are more than two conditions, then repeated measures ANOVA, or if the data is not normally distributed, non-parametric, Friedman test. So these are the tests. Okay, you always check, right? But now how to remember these easy? Okay, choosing the test, I'll tell you. Okay, I'll tell you choosing the test. I'll go to here. Here you will understand. This is the last slide, and it will take 5-7 more minutes. You will understand this easily. So guys, on the based of data type only. Okay, there are only two things you have to understand. One is continuous type of data, one is ordinal type of data, that is ranked categorical. Okay, based on that we are checking. So first let's check the ordinal type of data, ranked type of data. If data is ranked, if IV is, IV, the independent factor is ordinal, ranked, then which test we take? Normally what we take? Non-parametric tests, right? We take non-parametric test because data type is ordinal. That means there is no chance of normal distribution and there is no continuous data, right? So we will take non-parametric test. In non-parametric test we will see experimental design. What is the experimental design? Next part we'll see experimental design. So what is experimental design exactly? Here is like if there is pair or non-pair. If there are pairs, okay, if there are pairs like groups, okay, if there are pairs, not groups, if there are pairs means like one is today, one is after 1 month or whatever, tomorrow, or if there is repeated pair data, okay, and unpaired data. In the experimental design, if the data is paired or unpaired, first is type of data, ordinal, so definitely we'll take non-parametric test. And in that, then experimental design, paired or unpaired. If it is paired, then how many pairs? Two pairs, then Wilcoxon signed rank test. If more than two pairs, Friedman test. Okay, if more than two pairs, Friedman test. Now we will come to the unpaired. If the data is unpaired, then there will be groups. There will be groups. How many groups? If two groups, then Mann-Whitney test. If more than two groups, Kruskal-Wallis test. Okay, so you can check this. You can just confirm this in the last slides. Okay, you can just confirm in the last slide. See, Two groups, Mann-Whitney. More than two groups, Kruskal-Wallis. Two conditions repeated, Wilcoxon. More than two conditions, Friedman. Right? See, here same thing you will see. But it is easy to understand. It is easy to understand. What? Non-parametric test, experimental design, paired or unpaired. If it is paired, how many pair? Two pairs, Wilcoxon. How many? More than two pairs, Friedman test. How many groups? Two groups, Mann-Whitney test. More than two groups, Kruskal-Wallis test. Kruskal-Wallis test. Okay, and then if the data is continuous, then we'll check data is normally distributed or not normally distributed. If it is not normally distributed, we'll directly go to the non-parametric test. Directly go to the non-parametric test, because if the data is not normally distributed, then we don't need the normal experimental. Then we'll go for the non-parametric test only. If the data is distributed normally, yes, then we will go to the again thing, experimental design. And again, experimental design, paired or unpaired. If it is paired, then how many pairs? Two. Then in this we will take paired t-test. More than two tests, more than two pairs, ANOVA. Repeated measures, ANOVA. Here repeated measures, ANOVA. Then experimental design, if it is non-paired, like unpaired, how many groups? Two groups, unpaired t-test. More than two groups, ANOVA. Normal ANOVA. Here repeated measures, ANOVA. If it is repeating more than two times, if the continuous variable is repeating more than two times, then repeated measures, ANOVA. If it is repeating more than times, I'll repeat it once again for you guys. I'll repeat it. Very simple it is. You can make it, you can practice it at home making it. See, there are two types of data. One is ranked, one is continuous. So if the data is ranked, then directly we'll go for the non-parametric test, because that is the assumption. Right, in that we'll check experimental design. Experimental design means if there are pairs are always for continuous type of that data. Like we check today, we check day after tomorrow, or we check today after 1 month, baseline after 1 month, and baseline 6 months. There are multiple types of things, right? Pairs. So we'll experimental design, first we'll see for pair, right? Pairs. So now how many pairs? If there are only two pairs, then Wilcoxon signed rank test. Wilcoxon signed rank test. If there are more than two pairs, like we check today, we check tomorrow, we check day after tomorrow, three pairs, right? So if there are three pairs or more pairs, then we check for Friedman test. Simple. In that, if there is no pairs, if there are no pairs, then there will be groups. Okay, because here there will be groups. Continuous data, I mean, this is not the the continuous type of data here, categorical data, but there will be groups. In that there will be groups, like I mean, here we are checking the BP. Suppose in the paired we are checking the blood pressure, but unpaired we are asking for hypertension. Like at 1 month, at baseline, 100 out of 100, 60 were hypertension, right? After 2 months, we checked only 40 remains hypertension. After 6 months, 30 remains hypertension. So groups, not the continuous type of data, not the pairs, but there are groups. Okay, understand? There are groups, the same variables, but there are groups, not the pairs. So if there are pairs, then paired data. How many pairs? Two or more than two? Two, then Wilcoxon signed rank, more than two, Friedman test. Unpaired, like unpaired means group. There are no pairs, but groups. So how many groups? If there are two groups, then Mann-Whitney test. If there are more than two groups, then Kruskal-Wallis test. Okay, now it is for non-parametric tests, like ordinal data. If the data is continuous, now we'll check first thing, data is normally distributed or not normally distributed. Distribution only we can check in continuous, right? So if it is not normally distributed, then go for the non-parametric test. If it is normally distributed, again the same thing, experimental design, pairs or unpairs. I mean, paired or unpaired. Paired means like the continuous type of data, 2 times, 3 times. But here groups 2 times, 3 times, like 1 time, 2 times, 3 times. So paired data, how many pair? 2 pairs, paired t-test. More than 2 pairs, repeated measures, ANOVA. Groups, how many groups? 2 groups, unpaired t-test. More than 2 groups, normal ANOVA. Simple. It is very simple to understand, and that will be taught in the next classes. Okay, what's the difference between normally distributed and not normally distributed? So seriously, this table is superb for rapid revision of concepts in the biostatistics. This is like, so you can understand the things, and you will understand more when you are practicing it. Okay, when you're practicing it, what's the difference between normally distributed and not normally distributed? Okay, so as I gave you the example, very classical examples of like 10th standard. Okay, I'll give the medical example also. 10th standard, out of 100, 93 people are having 14 to 16 years of age or 17 years of age. But there are 7 people who have either extremely high, like 30, 35, they came later to join the school, or 40, like, so this type of data is not normally distributed because they have the outliers or extreme value. There are certain extreme values in all the type of data, but 1 or 2 are hidden. But if the extreme values are more than normal and impacting the mean, those are called as not normally distributed data. I mean, data is not normally distributed because the outliers or extreme values are impacting the p-value, I mean impacting the mean. Okay, these things are impacting the mean, so we don't consider we don't consider that for mean check, or we don't consider it at normal distribution. Okay, and if the data is already like, then if the data is not normally distributed, then what we consider it? Not normally distribution. Okay, not normally distribution, right? So this is very simple, guys, very simple to understand the things. Okay, and in medical terms, if I say, like like we are checking sodium for the people, it must be somewhere 135 to 145 normally, and someone's sodium is 196, someone's sodium is 194, someone's sodium is 210, and someone's sodium is 90, someone's sodium is 101, someone's sodium is 110. So these are the extreme values which impacts the mean of the entire population, and that is called not normal distribution. If the sodium are, I mean, normal value is 135 to 145, but if it is 130 to 150, all, that is normal distribution. Okay, that is normal distribution, right, guys? So that's all from this class, guys, and I'll share the feedback form, I mean the attendance form for you, right? And now I'll take the questions also. Please ask the questions. Your questions are welcomed here. And from the next week, Dr. Siddesh will be taking, or I'll be taking, I mean, whoever, we both will take the classes. So we'll be taking you through the tests, live tests. Okay, live test we will be applying. We will share the data with you before, uh, I mean, before in hand, we will give you the data sheets also. And then you can practice with us. Then you can practice with us. First, we'll tell you in the first class, like how to install the SPSS, how to run the SPSS, and then you can, work on SPSS with. Okay, yes, doubt. Who has doubt? Purna Chandra SM, please ask your doubt. How to learn, like how to put the test. You brought us what to put where, but how? That will be taught in the practical sessions. Then only you will understand. Then only you will understand in the practical sessions. Okay. Relative risk. Why not? So see, the relative risk is nothing but the ratio of incidences. Okay, ratio of incidences. Let me share the slide again once more, then so you can easily understand. Okay, you can easily understand, right? Okay, so see, relative risk is very simple. Okay, relative risk is very simple to understand. This is like, as I told you, how to check the incidences, right? So this is the risk of incidence of the problem, incidence of outcome. Disease or the death is outcome, right? Incidence of outcome in exposed people, incidence of outcome in non-exposed people, right? I'll give you another example. COVID-19, right? COVID-19 was there. So deaths among COVID-19 people, COVID-19 people, deaths among not COVID-19 people, like the people who did not get exposure to COVID-19. Okay, so we are just doing that right here. We are checking how much deaths are happening in COVID-19 and how much deaths are happening in non-COVID-19, right? This is the ratio, the new deaths, like a day. Like today, we are checking the deaths in COVID today. Like, okay, there are, out of 1,000, there are 120 deaths in COVID people, but only 10 death in like natural deaths, 10 natural deaths. So what is relative risk? 12. So we can say the deaths in COVID-19 people are 12 times higher than the natural deaths. Okay, 12 times higher than the natural deaths, right? So the incidence ratio among exposed and non-exposed is relative risk. Okay, and relative risk, if it is 1, then no association. If it is more than 1, as I told you, like 12, we got 12 in COVID and non-COVID, so it is 12 times higher. That means it is harmful. If the relative risk is positive, more than 1, that means it is harmful. If the relative risk come negative, like if like in COVID-19, not, we cannot suppose, but definitely if the deaths in non-COVID-19 are more than COVID-19, like here it is 120, but here it is 150, right? So what will be the ratio? What will be the ratio? Like there'll be the 4 divided by 5, right? So 0.8. That means this is protective. That means the COVID is not having more deaths than the normal natural deaths. So that is positive. That is like negative association is always positive and positive association is always negative. Negative means negative on the outcomes, negative in terms of outcomes and positive in terms of outcome. That is called as harmful or protective. Understand? I attended the previous class. We did not share the previous class. Third was the class 3 was was completely complimentary from my side. No feedback from for class 3. Come on, guys. It was complimentary from my side because you had the research cafe session that day. That's why we did not take the class 3 feedback or attendance. Okay, that was not necessary. Any other questions, guys? How to get the future? That is the next class, Pratibha. That is the next class. We'll tell you how to download, and I think we have shared one very important document how to download the software, but you download it in the next class with Dr. Shitesh. Okay. Okay. Thank you, guys. Then take care and fill the form, everyone. I'm sharing the form again and then we're leaving. Okay, guys, take care. Good night.